Hi ladies, this lecture is what I'm calling an addendum. It means a little bit more to what we did in class today. So what I'm going to give you are the 3 rules that you can use to do matrix row operations. So these are 3 rules that you can use on matrices. We used them today in class, but here it is in this video all spelled out. So the first rule is you can switch any 2 rows. So I could swap 2 rows. I'm allowed to do that. Rule 2, I can multiply any row by a constant as long as it's not 0, because that wipes out my row. The third rule is I can add 1 row to another row. The one thing that we may not do, and this was great because several of you asked if you could do it, is add a number to a row. So what we cannot do is add or subtract a number. Okay, so for example, what we can't do if I have this matrix M, I can't take the first row and say, let me just subtract 1 from each and get 2, 0, 1. Okay, that is what we cannot do. The reason is that these rows represent a system of equations. So this is 3x plus 2y plus 2z. Can I just turn that into 2x plus 1y plus 1z? Maybe you're like, I don't know, can you? Well, no, that would make it a different equation. Remember, this represents a plane. This would be a different plane, maybe a different angle. Okay, so we can't do that. So let's practice what we can do. We can swap any 2 rows. So let's swap row 2, which I've written R2, and row 1, which I've written as R1. So I could write -2, 9, 0, and 3, 1, 2, and leave row 3 unchanged. Okay, why can't I just swap any row? Because what I'm doing is I'm swapping systems of equations. So it doesn't matter which one I write first. I can write them in any order. That's nice. If you have a 1, you might want to put that up on the top because you want a 1 in the upper left corner. Okay, second thing I'm allowed to do is to multiply any row by a constant. So let's multiply the third row, R3, by the number 4. 4, 2, 12. Okay, I can do that. The reason, this is a system of equations, I can multiply everything by a number, and it's still the same. It's like if I have 2y equals 2x, it's the same thing as saying y equals x. I'm allowed to multiply the whole equation. Okay, what else can I do? I can add 1 row to another. So let's add row 2 to row 1. Let's add row 2 to row 1. So -2 plus 3 is 1. 9 plus 1 is 10. 0 plus 2 is 2. Notice that row 2 doesn't change. I'm simply adding it to row 1. Row 2 doesn't have to change at all. And of course, row 3 is untouched by this operation. Okay, then I'm going to combine two rules. Rule 2 and rule 3 together mean that I can multiply a row and then add it to another one. So let's add 3 times row 2 to row 1. Now I'm going to draw it in a different color just so we can keep track of everything. 3 times row 2, I'm just going to write it down here. Sorry, -3 times row 2 gives me 6. -3 times 9 is -27. -3 times 0 is 0. So that's what I'm going to add to row 1. What's row 1? 3, 1, 2. That gives me 9, -26, 2. So let's draw the whole matrix. I've added it to row 1, which means I write it in the place of row 1. 9, -26, 2. And the other rows remain unchanged. Okay, those are your 3 rules. So again, what can you not do? I can't say, well, I want this to be a 0, so let's just add 2 to this row and get 0, 11, 2. Okay, we can't do that because we're not allowed to do that to a linear equation, so we can't do it in a matrix. Okay, so just some practice. Let's turn, using our rules, let's convert this matrix A into the identity matrix, just using our rules. 2, 4, -1, 6. Well, I see there's a 1 there. So the first thing I might do is swap row 1 and row 2. So let's just swap them. -1, 6, 2, 4. Okay, then I want to multiply the top row by -1. 1, -6, leaving the bottom row unchanged. Okay, now I want to make this into a 0, so I can multiply the top row, row 1, by -2. I'll put that in a different color. So that's going to give me -2 and +12. And then I'm going to add it to row 2. So now row 2 becomes the sum of 2 and -2, 0, 4 and 12 is 16. And I have 1 and -6. Okay, now I can multiply any row by a constant. So let's multiply the bottom row by 1/16. That'll turn the 16 into a 1. And we almost have our identity matrix. All we need is this -6 to go away. So what should we do? Well, what if we took row 2, multiplied it by 6, and added it to row 1? We'll do that in green. Multiply row 2 by 6, so this becomes a 0, and this is a +6. And now let's add it to row 1. 0 and 1 is 1, 6 and -6 is 0. And that's how we get our identity matrix. Okay, that's the end of the video on just using row operations. The next video will be how to apply this to solve systems of equations. Good luck, ladies.